Hey guys, let's solve this problem, asteroid collision. So we are given an array of asteroids of integers representing asteroids in a row. For each asteroid, the absolute value represents its size and the sign represents its direction, positive meaning right and negative meaning left. Each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If both are the same size, both will explode. Two asteroids moving in the same direction will never meet. So example we have given like asteroids, and we have this the we have given this array like it shows us like their representation in a row, right? So we have five and it's moving to the right, and we have 10 and it's moving to we have 10 and the 10 is moving to the right, and negative 5 is means it's moving to the left, right? So the negative sign represents its direction in the right. The positive sign indicates its direction to the right. So how do we solve this problem? How do we how do we find out the state of the asteroids after all collisions, right? So let's say we know like we need to know like the directions, right? For example, which of the directions should bring the collisions, right? For example, if five and we have five and a 10, right? They are moving in the same direction, and that means they will never meet, right? But when you use the 10 and negative 5, 10 is moving to the right, and 5 negative 5 it shows it's moving to the left, so they will meet, right? And since as you can see, like since five is not going to let's say we have five, we found five, and five is not let's say in our state five is not collide, right? So in our collision array, let's say five, we have five and we have 10, but we got 10, right? We got negative 5, right? So 5 will collide with negative 10, right? So the their speed is also said their speed is the same, right? They are moving one they're moving one step per time in each of them, right? So their speed is the same. So 10 will collide with negative 5, but since negative 5, the size of 5, negative 5 is less than 10, it's gonna explode, and our state remains like this one, right? So it's gonna be negative 5 comma 10, right? But let's take another example. Let's take the last one, right? The last one is gonna be like the last one we have we're gonna have 10, and let's take 10 first. 10 is never collide with 2, right? Because they are moving in the same direction. But when you see negative 5 collides with 2, right? Because 2 is moving to the right in one step per time, and negative 5 is moving one step per time per each in to the left, so they meet, right? They would collide, and since the magnitude of 2 is less than the magnitude of 5, negative 5, so it's gonna the two, the one the smaller size is gonna explode, and we remove it from this state, right? So negative 5 will collide with this 10, and it's gonna negative 5 will explode, right? So it's gonna be negative 5 will explode with since the size of negative 5 is less than 10, negative 5 will explode, and our array remains with 10, right? So how do we solve this problem? So to solve this problem, we're going to use a stack, right? So we are going to exploit stack, and using stack, I think it's gonna be the time complexity would be O of n, and the space is gonna be of n also, right? So let's use a stack, and our stack is gonna be like one thing I didn't explain is that we need to know like what we have to know is like the the one in our stack, or the one we trying to find. I mean, we are trying to find for each asteroid moving to the right, we need to find the one that's moving to the left, right? We have to check that. That's the only way, the only one we have to check. right? So what I'm going to do is let's start from for each asteroid, let's say A, and we iterate over in for each asteroid. What we're going to check is while stack is not empty, we have to check whether it's not empty, and we have to check the top of the stack is has to be positive, right? It has to move to the since we are moving to the right, the stack the element at the top of the stack should be it should be positive, right? It should be negative. It should be positive. It should be greater than or equal to zero, and the one we are seeing from the asteroid for each asteroid, it should be negative, right? So so A has to be great is less than zero. So whenever this is the condition, the collision happens, right? The collision happens whenever this is true, right? This condition is happens. So how do we remove from outer state? How do we that? How do we do is that? So one thing we can do is, let's say we have collision variable, like we have collision, and we can add stack at the top, stop at the top, and plus the magnitude of the current asteroid. And if the magnitude of the collision is if the magnitude of the collision is if it is greater or if it is less than or equal to zero, or what we got to do is we can pop it from the top of the stack, right? So we pop it, and what if the collision is greater, right? If it is greater magnitude, right? If it has greater magnitude or equal to zero, we break, right? We break from the loop. And if the loop terminates normally, what we're going to do is what we are going to do is we append to the stack, we append the asteroid and return the stack, right? The stack is the final state of the collision, right? It's gonna be this one. Why? What? The reason why this happens is means if the collision is, I mean, if since we're the top of the stack is the one that is a positive sign, right? If it has positive sign, and if this magnitude is less than means if the top of the stack is less than to the one we're seeing, right? So it's gonna be so the collision is less than or equal. Well, it may be equal, but both of the time we are going to pop from the stack, and whenever there is a collision is greater than the top, greater greater means there is the one we have seen or the element we're traversing is greater magnitude than the one in the top of the stack. So we are now going to pop from the top of the stack, so we break, right? So so the time complexity is just O in time complexity is just O in, and the space is also space complexity is just it's gonna be of n, right? So we are so I have solved this problem in of n and of n space and time complexity, right? So let's see if it works or not. It's taking time, I think. Okay, go ahead. Okay. So as you can see, it passed for the given test cases. So let's see for all if it works for all the test cases. So as you can see, it passed for all of the test cases, beats this much of the Python user, and so thank you very much.